Hey everyone, thanks so much for joining. My name is Kevin Jones. I'm really excited that you guys are here today. We're going to be talking about Growik, a online platform for learning, and specifically the Solidity developer track. We're also going to be talking about Scaffold-ETH, which is a toolkit to build and prototype on Ethereum quickly. It's basically the backbone to the curriculum at Growik for the Solidity track. So really excited to have you here. And yeah, let's get going here. So let me just bring up my slides here and share my screen. And again, thank you guys, everyone, for being here today. Let's go ahead and fix my screen here. Let's do a slideshow and ready to go. So again, thank you so much. My name is Kevin Jones. I am a Solidity developer. I do a lot of different things, but full-time I actually work for a company called NGINX as a product manager and evangelist, which is a traditional Web 2 company. It's the #1 most used web server on the internet today. But I'm also a developer advocate for Scaffold-ETH, which is this awesome toolkit that I'm going to show you guys today. And I'm also the lead Solidity mentor at Growik. And if you're not familiar with Growik, we're going to talk a little bit about it, but it's an online learning tool that you can use to kind of learn at your own pace that is admissionless, collegeless, tuitionless. It is free, 100%, and they have a Solidity developer track, and so that's what I'm going to be talking about. And then in my free time, I'm a photographer and filmmaker, yeah, I do lots of fun stuff, and I'm excited to do some fun stuff today with you guys around Scaffold-ETH and Solidity. So a little bit about Growik. So Growik is it's an online platform, a learning management system that is designed to make education collegeless, admissionless, and tuitionless. And really, whether it's someone that's looking to just kind of learn a new skill or an alternative to college, it's a great place to gain knowledge and really just upskill your talents in a specific thing. Today, we're going to be talking about Solidity specifically. They have a track that's going to get you up and running on Solidity. And the overall goal of the program is to help web developers, traditional maybe Web 2 developers, get into Web 3, learn Solidity. Solidity is one of the core components to Web 3. And the program is designed to get you practical skills. So again, it is all built on Scaffold-ETH and this concept of building a dApp, or a decentralized application. And you actually will build a number of decentralized applications that are deployed to a public blockchain that you can there show to a recruiter or to your friends to showcase your skill in building on Web3. The duration of the program is about 8 weeks, and it's a total of 4 modules kind of divvied up. And it also consists of some quizzes and some tasks to kind of test your functionality, test your ability to understand the material. And there's also a bunch of mentors that are available, as well as myself, that will help you, as well as a Discord channel that you can get involved in the community. And it's a really good platform to build a community around. And so I highly recommend checking it out. And at the end of the program, you will get a certification that says that you have completed all the tasks in the Solidity development program. It's really easy to get started. You can just scan this QR code if you're at home, just bring up your phone, bring up the website. This is going to take you directly to the Solidity developer track. Click apply as a student. You can sign in with Google, just takes a second, and you'll automatically be enrolled for the program. And then from there, you can click on the tracks, click on the Solidity developer track, and you can get started. The next session for the next cohort starts on August 8th. So now is a perfect time to register and get going. And if you're available tomorrow, we have a special, awesome webinar that we're going to be doing, me and Austin Griffith. Austin Griffith is the creator of Scaffold-ETH, and we're going to go a little bit more into depth on the program and talk a little bit about the actual content that's in the program and why it's going to be useful for you as a developer. You can scan that QR code there and it'll take you directly to that site. That is also going to be on Eventbrite, so register for that. So let's go ahead and get started. So in order to understand, where we came from as far as where is Web3 now, it's good to understand kind of the history of the web, right? And I think a lot of you guys know this, but it's a good kind of refresher. Back in the 90s, early 90s, when the internet was really becoming popular, everything was considered what's called the static web, right? Simple static HTML websites. Everything was designed in a sense just to broadcast information from a website. Everything was very simple HTML. There may have been a little bit of JavaScript, but everything was deployed on bare metal servers, and things were a lot simpler then, right? And then the web evolved, right? Things got pretty complex. Late 90s into the 2000s, infrastructure expanded, this concept of distributed systems. Things were being moved from not only bare metal, but hosting on cloud providers, virtual machines came about, containers have come about over this duration of this kind of move to Web 2. And everything became built with like dynamic content, right? It was less about static content, it was more about the user interacting with the site. Information flowed between the app and the user and back and forth. And usually all the data was stored on databases or in a network storage, and it was sitting behind company-owned infrastructure, right? And everything got more complex, lots of protocols. This was the birth of APIs, which are like, a way for applications to talk to each other. And this also gave range to new and cool things, right? Instagram, Facebook, all these, MySpace, if you're old enough to remember, all these cool apps were built around this concept of this dynamic web. Web 2 to Web 3 it's a different concept, and it involves this concept of decentralization. So basically deploying your application in a blockchain-based way, right? So on a blockchain or some kind of decentralized network, where you have particular nodes or maybe providers that connect to the network. And basically, that is kind of like your entry point into the network. If you don't have your own node running, you can contact a provider like Infura or Alchemy or something like that, and you can create an API key and get access to the blockchain that way. But it's still decentralized in the sense that the nodes behind it that are running the blockchain are permissionless and decentralized. So permissionless, meaning that anyone can interact with them, right? Using public key cryptography or wallets, as you would know them, right? And everything is immutable and censorship resistant, right? So application logic is actually stored in what are called smart contracts that are deployed onto the blockchain. And so if you deploy and build an application, you can actually build it where it will live forever, right? And everything is transparent because all these transactions are being shared on the network and validated on the network. And so you can kind of trace and understand like what the blockchain is doing. Most people say like, oh, the blockchains are for, malicious intent and stuff like that. But really, actually, it's not. Everything is transparent. And unless you encrypt your data before you put it on some kind of blockchain, it's there forever, right? So what does that mean for developers? Well, most applications are being built on JavaScript frameworks, like something like React. This is like the front end, the front end of the dApp, something like React or Next. And the actual applications, static assets, HTML, JavaScript, images, all that good stuff, video, are usually deployed on a distributed file system or some kind of other decentralized network for storing files. So IPFS is a common one, interplanetary file system, which is basically this kind of like hashing mechanism where you can like deploy an asset, hash it, get the hash back, and then that asset lives in a decentralized manner and distributed across the IPFS network. There's also cool things like Arweave, which is a rather new protocol, but it's this concept where you pay up front for your storage costs, and then that storage can live forever. As far as the smart contracts go, these are the core business logic of your application. This is code that is written in popular languages like Solidity, which we're going to talk about today, or Viper. And this code is pushed and deployed out onto the blockchain that you're deploying. We're going to be talking mainly about Ethereum today. And everything is stored on these public verified blocks, right? And all of the logic is self-executing in the sense that you write the logic into your smart contract, and the way you write the logic defines how the behavior of your backend, your smart contract should work, right? And this removes the need for any intermediary. You don't have to go through a bank. You don't have to go through a hosting service. You don't have to go through any third party to interact with the blockchain. You literally could run your own node in your house, connect to the blockchain, and you're good to go. And these smart contracts actually can store value, right? We know that we can store like value because the native currency for blockchains are, deterministic of how they operate. So in Ethereum, in this case, is ETH, right? And all of the dApps, you can interact with them using special JavaScript API libraries, Web3 JS, Ethers JS. Scaffold-ETH, which we're going to talk about today, uses Ethers.js, which is, in my opinion, it's the far superior version to interact with the blockchain. And again, you can have providers. So you could have something like Infura, where you connect to the blockchain through an API. Or there's also, companies like Moralis, which provide nodes, or I think Infura actually does as well. Or there's like all sorts of other services built around this concept of decentralization. So as you interact with the blockchain, right, these blocks start building, and that's really what a blockchain is. It's these verified set of blocks that connect to each other. We're not going to get too much into that, but that's a basis for what we're talking about today. So enter Scaffold-ETH. So Scaffold-ETH, again, is this toolkit that is open source. It's available in Git, and anyone can go there and check it out. If you do a quick Google search, it'll be the first thing that shows up. All you have to do is check out the code, install the dependencies with Yarn. So the prerequisites are that you have Git, obviously, to check out the code. You have Yarn as a package manager to deploy your application and to spin up all the scripts that are part of Scaffold-ETH. And then you have to have Node.js. So you check out the repository, do an install, which we're going to go through today, do a Yarn chain, which spins up a local hard hat node. Now, hard hat is kind of like this Ethereum virtual machine that kind of you run locally that allows you to kind of simulate what transactions would look like on the blockchain. So Yarn chain will spin up your hard hat node for you. Yarn start will spin up a copy of React running on localhost port 3000. And then Yarn deploy will basically take the smart contract that comes with Scaffold-ETH. So it comes with like a basic smart contract, and it will deploy it to the network. It'll deploy it to this hard hat chain. And then as you interact with your React application, there's a bunch of other magic that's going to happen, and I'm going to walk through a little bit, where it will automatically grab your smart contracts API, which is basically this like compiled map that explains how your app works with React, automatically loads that in, it automatically loads in some functions, and it just does all this magic to get you up and running quickly. So we're going to talk about that. We're going to show how to do that. But then we're also going to show a special build of Scaffold-ETH today called the buyer mints branch. So the buyer mints is this special branch that's available that kind of allows you to pre-mint, or not pre-mint, sorry. It allows you to pre-upload all of your assets for your NFTs to IPFS. And then it allows the user of your dApp to go on, connect their wallet, and then buy the NFTs and pay for the gas. So it's kind of this like pre-way to get NFTs available and ready to be minted. So the only difference is that we're going to clone down the repository and we're going to check out a new branch. And I'm going to show you what the branches are and why they're important. But there's all sorts of examples on different things. And one of them is what I'm going to show today. Same process after that. Yarn install, Yarn chain, Yarn start, Yarn deploy, and then everything's good to go. So it's just kind of this one extra step where you're checking out this special repository. So if after today you want to get started, you can sign up for Growik. If you have problems with Scaffold-ETH, there's docs.scaffold-eth.io, and there you can kind of read all about Scaffold-ETH, and that'll also give you the links to like the GitHub, and there's also a Telegram channel. We also have the Growik mentors available on Growik, so if you're signing up for the course, you can get help through there as well. So without ado, let me end this, and let's take a look at the repository. So I just want to kind of show, or actually first Growik. So when you do sign into Growik, you can see here that we have like all of these courses that you take. There's one first course that you take that just kind of gives you an introduction to blockchain. Then there's a bunch of information on Solidity, how to build on Solidity. And then there's this whole section that is actually going through and doing real world applications, right? So as you go through, you get these instructions and you can get up and running. Again, everything is based on Scaffold-ETH. So if you do a Google search for Scaffold-ETH, the first thing that's going to come up is this GitHub repository. All those instructions that I just had in the slides are available here. They walk you through getting up and running. They tell you what the dependencies are, how to clone the repository, how to go into the repository and do the install, how to do the chain, spin up the hard hat chain, start, deploy. So all this is here. So don't feel like if you're taking notes at home and you need to keep track of everything I'm doing, because you can get it easily from there. And I talked about the special builds. If you go to the top of the left here, there's this kind of like branches tag for GitHub, and we could just look at like buyer mints. And then if we click that, So buyer mints NFT, it's going to take us to this special fork of Nginx or branch. And it's got a different set of instructions. So these instructions we're going to go through a little bit later as well. So if you want to replicate the buyer mints, go to Scaffold-ETH, and then you can get going from there. So eventually, when you go on your journey through Growick.com and you get going, eventually you're going to land on Speedrun Ethereum. Speedrun Ethereum is this kind of like set of quests that you go on, right? Where you actually go in there and do these examples. And one of these is the simple NFT example. I did a webinar on it about a week ago. You guys can find it on Eventbrite, or you can look on my Twitter and you can watch the replay as well. But with that one, we actually pre-mint the NFTs and we make the NFTs available on the blockchain right away. The difference today is we're going to make it so that the assets for the NFTs are uploaded, but the user of the dApp can then develop and build those, or I should say they can buy those NFTs using your dApp and pay the gas that it costs to basically mint those. And we're going to talk about gas in a little bit as well. But again, eventually you will get invited to the Build Guild. And as you complete these kind of challenges, you can show off the code. You click on the code, you can click on the demo, and you can share it on your social networks and show that you've actually gone through these challenges and you've learned along the way. So that being said, let's get started. First of all, I use tmux, which is just a terminal multiplexer. It allows me to have multiple windows up at once. The thing with Scaffold-ETH is you always have to have like a few windows up. So you can just do this in different terminals. So if you're using a Mac or if you're using Windows, just open up a few terminals. You'll be good to go. So I've gone through here and I've actually already downloaded Scaffold-ETH. So I've checked out the repository and I've also already done a yarn install. When you first do the yarn install, it takes about a minute, right? So you're going to get up and running by doing that yarn install, and it's going to install, basically it's going to install all the dependencies. So if there's anything that's needed for Scaffold-ETH to run, it's going to install it for you. That's it. Then you just do a yarn chain. So spin up a blockchain, right? That's it. We just yarn chain. Now we have an instance of hard hat running on our computer, a basically simulated version of the Ethereum virtual machine. So now I'm going to go over here to this next window, and I'm going to do yarn start. Yarn start is going to spin up a copy of React, and it takes a while. It takes about a minute to start. So we'll kind of let that sit while it's doing that thing. And then we're going to go into this third window. So those first two windows, you're always going to have yarn chain up. You're always going to have yarn startup, which is the React application, and those are going to be running all the time. So you can kind of keep those up so that you can see the traffic. Then we come to this third one, and this is really where you'll be doing all your deploys, and you do what's called a yarn deploy. So imagine yarn deploy is just this, it basically takes the hard hat script to deploy your application, and it looks inside the contract folder and it sees that you have a smart contract, which again, something is automatically basically, let's see if it actually, yeah, it did. So it automatically comes with like a hello world contract, which we're going to show today. And we can see here now that it deployed and it told us how much gas that we use. So it tells us the address for the contract, and then it tells us how much gas we used. So anything you do on the Ethereum virtual machine involves a little gas. You can kind of think of it as like your power that you're paying for. Your processing power, or if you're gonna change state on the blockchain, like update a variable, or if you're gonna push a code to the Ethereum virtual machine, or if you're gonna do some kind of transaction that actually interacts and changes something, you got to pay this gas. If you're reading for the blockchain, reading is cheap, reading is free, and you can read data. But when you actually want to change something is when it gets complicated, because you have to actually sign the transaction and do this kind of cryptographic function. So we see here that our blockchain's working. We can see some calls. We got some warnings. I don't know what those are actually, but we can see that React's up. So if we go back over here, we now have our Scaffold-ETH up and running. So again, I'm going to give you a real quick run through of it. But basically, there's all these tabs here. There's this burner wallet functionality, and then there's this gas station, and there's a faucet here. Now, this first tab here, the app home, is kind of like where you would build your application. So there's some like just examples in here of like where you would, how you would do different things, and kind of just giving you some guidance to get going. But really, if you want to start building your app and you're proficient in React, this is where you would build it. And it's available inside the code, and I'll show you where it is in a little bit. Then there's this debug contracts, right? So I think right now, let me do a yarn deploy reset, because I think something weird happened here. I'm not sure why, unless yeah, no. There we go. So sometimes you have to do a yarn deploy reset. Just so you know, that's kind of useful code. It resets your deployment. So the second tab shows you the contract, which is this hello world contract. It shows you the address for the contract, if it has any value. And then you can see here that in this contract, there's two things. There's a variable, which is called purpose, and it has this value of building unstoppable apps. And then you have this set purpose. So set purpose is a function that's written into this contract that allows me to update it. So if I wanted to interact with this smart contract, I could be like, Growick is awesome. I spelled it wrong, but that's okay. And I'm going to try to, and it's going to say, oh, well, I don't have any money. So I don't have any money to pay for the gas to change the state, basically. So if you look here, there's this kind of like burner wallet that comes in with Scaffold-ETH. It's actually built into the browser. So you don't need to use MetaMask, or you don't need to use any kind of like third-party wallet. You can just use this burner wallet. And you can also just quickly grab some funds from it by clicking that button right there. So now I have some money to play with. You can think of the money is coming from Hardhat, and it has a bunch of Ether for you to play with. And so when you click that button, it just takes some of that Ether and sends it to your burner wallet that's in the browser. I could also grab more if I wanted to. I could come down here, click the wallet. I could put my address in here, and I could give myself, I don't know, let's say $1,000 and send. So now I just sent $1,000 in ETH from this Hardhat instance to my wallet. I wish it was that easy in production, because then I would be rich. But you get this idea. It's just this toy money that you're playing with. You can also do things like export the private key if you wanted to, because it just generates a random private key. You can send Ether to another account or to the contract by sending it here. Like, let's say I wanted to grab the contract address, and then I want to send it some money. I could be like, oh, let's send $100 to this contract. Send. And so now this contract actually has some value associated with it. Say it has $100. So I basically transferred some money from my wallet into the contract, and now it's there. But guess what? It's lost forever because I don't have any way to pull the money out. We're going to get to that in a second. And then you have some other stuff here, like you have these hints, which allows you to kind of like see like how you would build UI components, or how you would access like the balance of the wallet, or how you want to like scan or pick a token from a list. And these are all available in the source code. Then you have this example UI, which again is examples about how to like kind of interact with your smart contract in a UI based way. And then you have like mainnet DAI, which is a copy of the mainnet DAI contract so that you can send around stable coins. DAI is a stable coin. You probably won't use this much. And there's also a subgraph endpoint for if you want to build a GraphQL API for your blockchain data, you can go through these instructions and spin that up. So that's a real run through of Scaffold-ETH. That's really all I wanted to show in Scaffold-ETH right now. I do actually want to show you the contract real quick so you can see what this kind of hello world contract looks like first. So I just loaded up the entire directory structure in what's called Atom, which is basically just a text editor. You can use anything. And you can see that the directory structure has this packages folder right here. And it also has 3 different folders inside there. It has React, it has Hardhat, and it has a services folder, and it also has subgraph. You really, when you're developing in Scaffold-ETH, the most common places you're going to be are in Hardhat and React, right? Inside this Hardhat directory, there's a contracts folder, and then inside there is this your contract. So your contract is kind of like the hello world contract. And so we can see that we have a string, which is a variable that is defined. And we also have this function, this hello world function. So that's cool. It allows us to update our function. I could come in here and I could say like, I don't know, permissionless apps like that, save that, and then come over here and do another deploy, and then go back to the app. And then we kind of give it a second, and there it is, updated. So you're kind of going through this process where you like coming in here, you're coming into the source code, you're making some changes, then you're coming over here deploying, and then you're going back to your app and testing that kind of the assumption of what you're trying to accomplish with building the application. So let's just do a couple things real quick. Let's just show you how you might do something. So the first thing you might require is like that the user is maybe you have a special function that you want to write that is only the owner can access. So you could do access control. So you can import an existing smart contract. So Solidity has this concept of inheritance, where you inherit a contract from another contract, and you do that by doing an import. And in this case, we're grabbing the Open Zeppelin standard for what's called ownable.sol, which is just access control contract. And OpenZeppelin is like a collection. It's actually a company that has a collection of contracts that are kind of like industry standard. So I can import it, and then I can come over here and I can say is ownable, save that, deploy the changes. And then I'll get another additional field here after the deploy is successful that says owner. And this is the owner of the contract. So you can see it doesn't match our burner wallet. And that's because it uses the hard hat's first account available, which is contract zero, or sorry, account zero, which is the deployer account. And we could transfer that, which I'm not going to get into till later, but if you wanted to, you could transfer this to your like MetaMask account or to your burner wallet and stuff like that. But I'm just showing you kind of how you can tinker around. You can also do things like, I don't know, like if you wanted to do another variable, like you could do like address owner equals something like this. You could grab your address and then you could paste it there. You could do it a different way. Like, let's get rid of this. Let's actually go back to what we had before. Let's save that. And then we could do something like a require statement. We could say like require message.sender equal owner, not the owner. This, boom, save that, deploy it. So you can do all this kind of cool stuff. I think I spelled something wrong. Oh, when you do the address, you can't do it as a string because it's not a string. So let's fix that. Deploy. So now we've gotten rid of the access control module, and then we did it hard coded our own way. And then we can see now that we should have a new variable. Oh, I didn't make it public. So we got to make this public because it didn't show up here. If you want it to show up in React, then you got to make it public. So you get what I'm trying to show though, is you start kind of like building out your smart contract, deploy the changes, see those changes take place in the UI. So now we can see that the owner matches because we hard coded that variable. And then now if I was to come over here and do like, I don't know, let's bring up an incognito window, right? And let's go back to our dApp on this incognito window, right? Let's go localhost 3000. And now we're this kind of like incognito guy. We have a different private address that's inside here. And then let's go to debug contracts now. And we can see that we have some ETH. I don't know why it only says a penny, but I should have more than that. So now if I come over here and I want to update it to Growick is cool or something like that, and I try to, it's going to say you're not the owner because we're doing this kind of require statement, right? So you see what I'm doing? I'm testing, right? I'm like bringing up another browser and seeing what my behavior looks like. Now, if I come over here, say, well, Growick is the best or something like that, boom, hit send, then it let me because this is the owner and my private key that I signed the transaction with matches who the owner is. So I'm actually able to prove that I'm the owner. So you get the idea. So now let's close this out and now let's get into this special build, right? So for this, I'm gonna use another directory that I already checked out. So I'm gonna stop this version of Hardhat. I'm gonna stop this version of React, and I'm gonna come over here to this next tab. And I've already gone ahead and checked out the special branch called buyer mints NFT. And I've already done a yarn install as well. So we can do a yarn install and we can see that I've already gone there and did those requirements. So now I can do the same thing, yarn chain, right? And let's come over here. Let's do yarn start, spin up React, come down here. We do yarn deploy, boom. Let me go back to here. Let me close out the old code because we're going to use a new one now. What's going on? Oh, I got to, okay. So this is a good point to see. There was one extra step that I forgot. So this special build of Scaffold-ETH, the buyer mints version, it has this, let's open up the directory structure real quick. Let's take a look at it. So I showed you guys earlier that there's the hard hat and then there's the React app, right? So there's a special file in here and it's called upload, okay? And you can see if we look right here, what it's doing is it's actually uploading it's loading in a file called artwork.json, and then it's basically taking that JSON file and uploading all of the metadata to IPFS, right? And what this allows us to do is just put the metadata on IPFS, get these unique hashes, and then it builds a set of React components that allow the app to see those NFTs. So all we need to do is, let's see here. So here's the artwork JSON file. So let's just say that you wanted to build your own NFT. We're going to utilize Austin Griffith's amazing artwork that he's created. And it's all these NFTs are actually on his website. And you can see like some examples of what those look like. So this one's a buffalo, and it has a link to his buffalo painting. We also see that there is an image. If you just join, please go on, make sure you're on mute. And you can see there's a link to the image, and then there's a attributes file. And so like these attributes, you can think of with NFTs, pretty much the NFT that you mint points to this kind of like JSON structure. And this JSON structure is kind of like a guide for the NFT on how to display properly. So an external URL is just for anyone that owns the NFT that can navigate to see where that lives in the real world. And then the actual image is what the image should look like for that NFT. And then these attributes allow you to kind of like customize the NFT. So you often hear like, well, what is the real utility of NFTs? Well, it really allows you to do these kind of like unique token-based attributes for a specific token. So you can see here, there's one called Bison. It has a description, it has a color of green, which is the background, and it has googly eyes, and it has stamina 42. So stamina could be like if you wanted to like make a NFT game or something like that, you would do that. So there's a bunch in here. So if you wanted to, you could write your own kind of metadata here. And then when you do come over here and you do a yarn upload, let's just go ahead and start it. What it's going to do is say, all right, let's load in that artwork JSON file, and let's start minting, or not minting, let's start uploading the metadata for each particular entry into IPFS. And then you'll notice that we get back these hashes. So I mentioned earlier about IPFS. IPFS is this kind of like file system that's all hash based. So you can literally just connect to a gateway or through IPFS in some way, using either the SDK or using a gateway, HTTP gateway, and you can just pass in the hash and you can get back the metadata or the file, even if it's a file like an image, a video, or something like that. So what this script is doing is just grabbing that JSON, putting it on IPFS, and then getting back a hash. So we're getting out all the hashes. Then it's taking those hashes and it's building the necessary components for the dApp so that the dApp can automatically know where what those hashes are and how to properly mint the URLs to the NFTs. So as soon as this is done, we'll come up here and we'll just restart React real quick too as well. While that's doing that, let me come over here back to the hard hat thing. I do want to showcase, there we go. It's not done yet. I do want to showcase one other thing. So let's look at the contract. So the contract is a lot different, right? So earlier it was a real basic hello world contract. There's not really a lot going on. This contract is using inheritance automatically out of the box. So it's using two different Open Zeppelin standards. One is called ERC 721, which is the kind of like the standard for single NFTs or just standard NFTs. It's called ERC 721. And then it's also using counters, which is basically a way to keep track and count a series. So imagine like with NFTs, they have an index or like kind of like an identifier, an ID. And so that counters is useful because you can just instantly count up. So we're doing some inheritance, and you'll notice here that we're inheriting this ERC 721 standard from Open Zeppelin. There's also some interesting stuff going on in the constructor. The constructor is what runs when Solidity is first deployed, when your smart contract's first deployed. So you can see that there's a name, there's a token symbol, there's the base URI that we add, which is basically telling our NFT contract where to grab the metadata from. So imagine that at the end of this will be the hash that we talked about earlier, this here. And doing a lot of other stuff, setting some mappings, keeping track, but then there's this mint item function. And the mint item function is basically allowing us to actually mint NFTs. So I'm not gonna get too much into this, but my point is that I'm showing you is that there's automatically a different kind of hello world contract. And if you want to learn more about NFTs, I would dive into this ER721 Sol and kind of learn about how that works. So, okay, now that's done. So we did the upload, all the metadata has been hashed into IPFS. And let's start up React one more time. Oh, sure it's spinning up right. Reload. It might take a sec for that to load. So while that's doing that, so the React app, let's take a look at the React app code because I haven't really talked about that at all. Inside the React app, there's this source directory, and then there's this app.jsx file. You can think of like app.jsx as like the index. It's like the very first, it's what the index actually points to when someone navigates to the root of your application, right? So there's a bunch of already stuff put in here that kind of gets you up and running. Things like the burner wallet, the connect button for if you want to use MetaMask, the Web3 modal. There's ETH hooks is already hooked up in here, and there's a bunch of other interesting like components that you can utilize out of the box, like getting the address of a balance or something like that, or the balance of an address. It automatically has this way to do like a specific network. So we're using localhost. If you want to deploy to like a test net, you could just update this to the right test net, and it will automatically determine. And so if you want to start building your app, you want to go into the views folder, and then there is the index.js. I believe that's where actually, let me, yeah, I think it's here in the index. So the example UI is the one that shows you the example UIs. Hints gives you some hints on how to deploy your contract. And then index.js, I think, is where you would build your app, I think, if I'm correctly. Okay, so, all right, so React is now up. So let's take a look at the app and let's see how it's a little different. So first of all, it's kind of weird, it's not loading. Oh, I didn't deploy the contract yet. So that after you upload all your assets to IPFS, then you need to deploy the smart contract. So what that's going to do is it's going to take the smart contract, deploy it, the one that I just showed you here in Atom, this one here. It's going to deploy it locally to Hard Hat. And then we should be able to come in here, make sure it deployed. And then now we're going to see all of our NFTs. So again, what the app is doing is it's just building all the assets for the NFT into the front end. So we haven't actually minted any NFTs. We've just kind of like built the groundwork to be able to mint NFTs. So at this point, we can start minting NFTs. We can grab some funds from the faucet because this wallet is empty because it's a new branch of Scaffold-ETH and it's a new application. And then we can pick one. So I'm just going to grab, I don't know, let's grab the lobster. Lobster's kind of cool. I don't have enough gas. So let's make sure I have enough gas. Let's grab my address here. Let's send $1,000. So I have a little bit more to play with because the gas to mint these are a little bit more expensive. So let's mint. And it was successful. So now I can come to my Your Collectibles tab and we can see that I was able to mint an NFT. Actually, it should show up. Let me try one more time. There it goes. I'm not sure. It takes a second, I guess. So anyway, so now if I wanted to, I could actually like transfer the NFT if I wanted to. So I could like click on the NFT under Your Collectibles. Okay, so there we go. I minted two different ones. So now I can open up this incognito window like we were testing before, and we can go to localhost 3000. We'll get a new address here as well. And this we can get some money from the faucet, and we go to Your Collectibles. We can see that there's none, but let's grab the address from this wallet. And I don't know, let's send both of these over there. We can just do transfer. And basically we're just taking these NFTs, sending them over to this other address. Then we can come over here and these NFTs should show up. There they go. So we were able to make it so that the contract was deployed, the smart contract was deployed as a, kind of like this factory, I guess you would say, where you can deploy your assets ahead of time, and then users can just come in, and as they click this mint button, it just takes the metadata address that you do here in the hash, and then it sends that to the smart contract and allows you to mint the things. I do want to show you real quick as well, like there's this transfer section that shows you all of the events. So anything you do in Solidity, you usually want to issue an event. And so you can think the event is kind of like a log where you're like keeping track of something that happened. So we can see here that we created some NFTs, and then we also transferred, we transferred the NFTs around as well. So I think first the NFTs were transferred from the contract to me. So basically the contract created these NFTs, and then the NFTs were transferred from me to another address, which is this kind of incognito window as well. I don't know why that keeps coming up. And then there's a couple other interesting things here for understanding how IPFS works. I talked about the metadata. So there's this cool option here where you can just kind of like edit in real time. So like if I wanted to like edit this, I could say, I don't know, whatever I want. It's actually a chicken, right? I don't know why that's not working, but I could like update the URL. I could do all this stuff, and then I could upload a unique IPFS hash right here in the browser, which should just take a second, but it will upload. And then you can also download that as well. So like, let's say I wanted to grab one of these hashes to see what it looked like. I could grab the hash and paste the hash here. Let's try one more time, down to the IPFS. I don't know why that's not working. This should, when you download from IPFS, it should show you the string of the, there it is. So this particular one is IPFS here, points to the killer whale, which has the name, the description, the external URL, all that stuff. So we could just copy it if we wanted to see it. And then we still have this debug contracts as well. And again, you'll see the debug contracts is kind of like a little bit more involved, because it's inheriting everything that ERC 721 standard has. So if you want to kind of understand all of the methods of ERC 721, then you'll want to kind of understand, like, there's the transfer from option. There's also the owner of, so we can see who owns a specific NFT. We can see if it's approved to be transferred. We can see if it's for sale. Like if you wanted to put it up for sale, you could set like a Boolean that it's true. There's all this kind of like functionality that's kind of out of the box. So that's pretty much all I wanted to go through on the demo. So I'm going to stop sharing, and then I'm going to see if anyone has some questions. So if you're on the Zoom, feel free to come off mute, and I can answer questions. I can also dive deeper into certain things for people as needed. No chat questions. So yeah, I know it's a lot to kind of go over all at once. It's a little bit of a slam, but the overall goal for Growick is that you can join the course. The first pretty much half of the course, you're just going to be learning Solidity, learning and understand about variables, about functions, all of the actual code. And you'll be using Scaffold-ETH to kind of do some tinkering and testing and kind of just building on your own and testing your assumptions. And then eventually you're going to get into the speedrun Ethereum, where you're going to go through and do these challenges. You're going to do things like create your own NFT project, build a DEX, build a dice game. And then eventually on the very final step, you're going to actually build your own dApp, build your own application. So the goal is by the end of the entire program, you'll be competent to really build your own application with no problem, all built on Scaffold-ETH. So yeah, I hope that was valuable. I hope that it was good information. Real quick, any other questions? Anyone else want to come off mute and ask questions, or you can type them in the chat? No? Okay, cool. All right, well, thank you guys so much. Yeah, I hope it was useful, and I hope to see you guys tomorrow for the session with Austin Griffiths, where we're going to dive deep into the curriculum and speedrun Ethereum and all the good stuff that comes with Scaffold-ETH. So I'll see you guys tomorrow.